Have you ever wondered how pH indicators work? Well, in this video, I'm going to discuss about the marvelous color changing ability of a pH indicator. As discussed in my previous video, a pH indicator is a weak organic acid or base. And as a weak acid or base, it ionizes slightly in the solution. Now the key thing to remember is that the color of an indicator depends largely on the proportion of ions and molecules that are present in the solution. And that's because the color of the ions and the color of the undissociated molecules are different. But the degree to which these molecules will dissociate is affected by the pH or the hydrogen concentration of a particular medium. So in essence, we're saying that the pH affects the rate of dissociation, and this in turn affects the color change. Now let's take an example, phenolphthalein as our indicator. The phenolphthalein is a weak acid represented with this formula. Now the H in that formula represents the hydrogen ion, while the IN represents the indicator ion. And this is actually a huge chemical formula, but in this video I'm going to shorten it as IN. And this ion is the negative ion of this acid. The H ion molecule is colorless, while the indicator ion is magenta in color. But in a neutral medium, this molecule would dissociate to give two ions, which are the hydrogen ion and the indicator ion. But because it's a weak acid, it ionizes slightly, and the backward reaction is favored most of the time. As a result, phenolphthalein is colorless in a neutral solution. Now we're going to discuss about two other conditions under this phenolphthalein. We're looking at the alkaline condition and the acidic condition. To start with the alkaline condition, in an alkaline medium, there are several species of ions that are present, which are the hydroxide ions, hydrogen ions, metal cations, and indicator ions. When these ions are together in a particular medium, the hydroxide ion reacts with the hydrogen ion to form stable water molecules. As a result, more hydrogen ions are removed from the solution, as the water molecules do not dissociate readily to form hydrogen plus ions and hydroxide ions. Because of this removal of these hydrogen ions in the solution, the indicator molecule is forced to give out more hydrogen ions to compensate for the loss of the hydrogen ions. Now this is correspondence with Le Chatelier's principle. As a result, the amount of indicator molecules present in the solution is lesser than the amount of indicator ions that are present in that same solution. Therefore, in an alkaline medium, the indicator appears to be magenta because the indicator ion dominates the solution. Now, let's discuss about the acidic medium. In an acidic medium, there is excess hydrogen ions because of the strong acid that is introduced. Because of this, the backward reaction is favored, forming more indicator molecules so as to stabilize the excess hydrogen ions that are present in the solution. Therefore, more indicator molecules are present compared to the indicator ions in that solution. As a result, phenolphthalein would appear colorless in an acidic medium because the indicator molecules dominate the indicator ions. I hope you have now heard the secret behind the color shifting ability of a pH indicator. If you want to see this color changing wonder in your own home, hit that subscribe button, turn on your notifications, as I will teach you how to make your own pH indicator at home. Thanks for watching, guys. If you have any questions, you can use the comment section to relate them so we can discuss about it, and I'll see you in my next video.